Yo, welcome to Gibbo Garage. Today we're going to be checking out the condition of your fuel pump using some current waveforms. We're going to be using a PicoScope and a PicoScope kit and software. So here we've got a little test mule, our 1.6 litre VW Golf AFT code engine. So we've got our scope set up, and today we are going to be using one of these lovely little fuse jumpers. Take the fuse out, put it in there, insert that into where the fuse goes, and a handy little pigtail to chuck our amp clamp on. So that's our in-car setup. I've had to balance the amp clamp on all the blocks of wood so it doesn't pull the little fuse body out of the fuse board. But we've zeroed the amp clamp and connected it up to the scope, and now we're ready to take a reading. I'll just take you to the scope and we'll have a look at some scales. So to get the waveform, I'll simulate getting into the car, unlock it, open the door, turn the ignition on, and that will prime our fuel pump. Turn it on for a short while, raise pressure in the system, and then it will turn it off again afterwards. So now we should have captured that waveform. Let's pop over to the scope and have a little look. So let's have a little look. We start out at 0 amps and a nice little spike up to about 10 amps before quite quickly dropping down to, let's say, just under 5 amps. The remainder of that line during the prime. Now, as we scroll across the screen, showing you the entire prime event. There's the end of our priming event when the pump drops off down to 0 amps again. When the pump drops down to 0 amps again, that's the end of our priming event. Now, let's go back to the beginning and see what we're actually looking at. So, at the beginning, over here, this spike up there is the pump overcoming its internal resistance and fuel pressure and all the other bits of resistance it's got against it. That takes the most amount of energy to start the pump turning, and you see this hump is the windings passing the magnet that's creating that magnetic field, dropping down, slowly getting easier as the pump has some more momentum until we're running up to speed, at which point each segment is nice and even and there's no dropouts all the way along. This is looking like a pretty good fuel pump. So just to make it a little bit clearer, I've pulled up the screenshot for you guys. There's a lot less glare now. And what we're looking at is another little feature that the Pico has. It has an RPM calculator function. So in this case, we know that this pump has 8 commutator segments per each revolution. So we want 8 humps, and each 8 humps, the pump will have done 1 revolution. Now, using this and a little bit of maths, or some of the Pico features, we can calculate what speed the pump is running at, and that's going to give us another idea as to how well it's performing. So in this situation, our pump's doing 1 revolution every 15.8 milliseconds. Now we can either do the calculation as per later on in the video, or we can use the 2 cursors in the time direction, and down at the bottom right hand side of the screen, I don't know if you can see it if you're zoomed in enough, there is a little box showing the RPM and the frequency in hertz. Now this feature is very useful as it calculates very accurately, very quickly, what our pump is doing. In this scenario, our pump's doing about 4,000 revs, RPM, and that's exactly what we'd expect. So we're going to call this a healthy pump. So just to finish off quickly, guys, I've got the printout of the waveform, and I'm just going to show you the calculation by hand, as it were, for calculating the pump RPM. So if we take revs per minute and take that into milliseconds, that gives us 60,000 milliseconds in 1 minute. And if we've only got one revolution happening, we measure that in milliseconds and chuck the time of that revolution underneath the total amount of time in RPM. Should look something like this. So one revolution takes 15.8 milliseconds. Always divide that by 60,000 because RPM, and we are left with exactly the number that the Pico calculates, but it's just taken us an extra 30 seconds to calculate this. But it's a nice way just to check what the software is doing, but as always, the Pico's got your back. If you've liked videos like this, please like, share, subscribe, and if you've got any comments on the testing methods you've seen or you want to include some of your own, drop them in the comments below. Until next time.